Number 2, I have to find the general solution of this differential equation, and notice it's using that differential operator notation, but that makes it easier because I can see the characteristic equation is essentially the same as my differential operator notation. I get a characteristic equation of r plus 1 cubed, r squared plus 1 equals 0. And so I know that I get r equal minus 1 3 times. I'll go ahead and write it 3 times. And this leads to r squared plus 1 equals 0, which is r squared equal minus 1. That is, r, when you take the square root of both sides, is plus or minus I. So plus or minus I is also part of my solution set. And so I get 5 functions involved, and here's how it looks. The general solution would be c1 e to the minus x. Then there's a repeated root, so I know that I have to do c2x e to the minus x. It takes care of 2, and then there's another one, so that's going to be c3x squared e to the minus x. And then the non-real root here, I have a real part of 0, so it's going to be e to the 0, so c4 e to the 0, which is 1, cosine 1x, because it's plus or minus 1i, so it's cosine 1x, and then c5 sine 1x. And that would be my general solution for that one. And number 3 is similar. Again, I'm trying to find the general solution, and I've been given this differential operator notation, and so I can easily see the characteristic equation is r plus 1, r squared plus 1 squared equals 0. And so just like before, I get r equal minus 1, but only one time this time. And this, we already saw that that's going to lead to plus or minus I, but I get that twice. So I get plus or minus I, plus or minus I. So this time, I get c1 e to the minus 1x, and then c2 e to the 0 cosine 1x, and then c3 e to the 0 sine 1x. That takes care of that one, but then it's repeated. So to repeat it, I get c4 x e to the 0 cosine 1x, and I get c5 x e to the 0 sine 1x. And so that would be the general solution in that case.